All right, we started your notes today by listening to the classification of matter song. And let's pause for a minute and think about all the different ways that they described matter's classifications. So let's pause right here for a second and you tell me what you remember from the song. All right, so the basic unit of all matter is the atom, as we mentioned when we started talking about matter and how it changes last week. And so atoms are the smallest unit. And atoms are very, 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 very small. And an atom is made up of three particles, the proton and neutron, which we know from our atomic history notes are found in the nucleus. And then the electrons are found in the cloud surrounding the nucleus. And each element has a different atom. So when we think about the 118 elements on the periodic table, their atomic structure is different, and the difference in the structure is the number of protons, neutrons, and electrons they have. That's what makes each element unique. Now, we're going to go through these notes, and I wanted you to get that written down, and I want you to write down the definition on the next slide of a pure substance. And then after that, I'm going to talk about elements, compounds, and mixtures, but then we're actually going to make a foldable, and you are not going to have to write these definitions down. Your foldable will become your notes, but you do need to get the next one down about a pure substance. So, a pure substance is defined as a sample of matter that has definite chemical and physical properties. So all of the 118 elements are considered pure substances, and all of the compounds are considered pure substances because they have a unique chemical structure. Now, mixtures are not considered pure substances. They're considered mixtures of pure substances or mixtures of mixtures. And I know that's confusing, but we'll get to the definitions in a minute. But again, the elements are pure that cannot be broken down into any simpler substance by a chemical reaction or by a physical change. So if you split the atom and break it into its parts, that is not a chemical reaction, that is not a physical change. You're just breaking it into its pieces. Like your body parts are not, don't have any purpose in separate form. So the proton, neutron, and electron needs to be a part of the atom to have a purpose. So we don't get any smaller than the element to really be considered a pure substance. Then we call molecules are composed of two or more elements that are joined together by chemical bonds. And I know this is a little confusing, but there's a slight difference between compounds and molecules. All of our compounds are molecules, but not all molecules are compounds. So look at the examples down here. You've got the sugar molecules, C6H12O6, that's a form of sugar. And you've got H2O, which is a water molecule. They are considered molecules and compounds because they have two or more elements joined together. Okay? And compounds have to have different elements joined together, whereas a molecule just can be any element. So if you look at my diatomic elements that are below, they are molecules of themselves. So I call them the twins of the periodic table. So when hydrogen pairs with itself, nitrogen, oxygen, fluorine, bromine, chlorine, and iodine, and they make a little 7 on the periodic table, that would be our diatomics. They're always found as two atoms in nature. You never find a single atom of these 7 elements on the earth. You always find them in diatomic form. Now, compounds, like I said, all compounds have to be two or more different elements. So water, salt, as you see below, are both compounds. Again, they're chemically bonded together. They're in a specific ratio. Sometimes you notice the 2s or the 6s or the 11s or the 12s or the numbers, and that indicates the ratio. It's kind of like a compound, I say, is the recipe. Elements cannot bond any old way. 5 hydrogen and 6 oxygen do not make water. It takes 2 hydrogens and 1 oxygen to make water. So there's a specific way it has to happen. And another chemical reaction has to take place to break that compound down, or for that compound to get rearranged and form something new. All compounds have different chemical and physical properties than their original elements. And think about that. Hydrogen is an explosive, flammable gas. Oxygen is an explosive, flammable gas. But yet when they combine and make water, they're neither flammable nor explosive anymore. The most common state is now a liquid, and they will actually put out a fire, the opposite of being flammable. And then salt. Sodium by itself is very explosive and dangerous chemical. Chlorine can be a poisonous gas that kills bacteria, but yet when they chemically bond and form table salt, NaCl, we use that in our food, and it's neither poisonous nor flammable. In fact, table salt can, again, put out a grease fire. So their chemical properties and their appearance changes. Now, mixtures are not pure substances. They're a combination of two or more pure substances, so they can be combinations of elements, they can be combinations of compounds, they can be combinations of elements and compounds, they can be combinations of elements, compounds, and mixtures to make another mixture. But they're not chemically combined. A chemical reaction is not taking place. They retain their original chemical and physical properties, and they can be separated back out by filtering, sorting, or evaporating. It doesn't take a chemical reaction to separate them. So if you look at my picture there, I've got trail mix. That is a mixture. A bunch of stuff been thrown together, tastes good. I can still separate it out into its different parts. So it is a mixture. Now, mixtures can be broken down into different types, so their classification. There's another way to classify. Homogeneous mixtures means they look the same throughout. Their molecules are evenly distributed. You're not going to see the parts. We often call them solutions and colloids. Kool-Aid, coffee, gelatin, mayonnaise are all homogeneous mixtures. Heterogeneous means the molecules are not mixed evenly. You're able to see them. So a snow globe, muddy water, those would be suspensions. And that's where we're going to stop and put our foldable together. And we will put it together and get it in your notes, and then we can start. I've got one more demo to do for you, and then we can start working a little bit on recognizing how would we recognize the differences in this classification.